Hi, I'm David Stevens. I'm a program manager on the .NET team for Visual F#. And today I want to show you how to get started using F# on .NET Core. But before I do that, I thought I'd take a second and explain what's F# and what's .NET Core. So F# is an open source, functional first programming language on the .NET platform. In a functional programming approach, you model most of your program as a bunch of functions that take immutable data as input and produce immutable data as output without performing side effects in between. F# isn't just a functional language though, it also provides object-oriented features like classes and inheritance. And its design harmonizes these object-oriented and functional paradigms so that you can write code with whatever tool makes more sense for the task at hand. F# is a .NET language, so it runs on .NET Framework, Mono, Xamarin, and now .NET Core. Its design makes it easy to interoperate with C# and VB libraries. And this is great for a couple of reasons. The first is that F# programmers can use the huge .NET library ecosystem that exists in a really nice way. And it also makes F# easy to adopt on teams that already have some .NET code. So you can incrementally write some F# code, and C# programmers and VB programmers can just use that F# code and kind of be none the wiser. F# has awesome IDE and editor tooling support in Visual Studio, VS Code, Xamarin Studio, Atom, Emacs, and a whole bunch of others. The spirit of F# is really about using simple code to solve complex problems. F# is used to solve a wide variety of problems, including UI, web automation testing, web services, scientific computing, really a huge range of different things. And it's used by a lot of different kinds of teams, from individuals to startups to Fortune 500 companies. They're using it in production today. So that's F#. Now what's .NET Core? .NET Core is a new cross-platform, open-source, modernized version of .NET. To meet the needs of even more developers, we made .NET Core cross-platform, so in addition to Windows, it can run on your Mac or your Linux PC. .NET Core is open source, and that includes the runtimes, the libraries, the tooling, and the languages. So you can contribute on GitHub right alongside the Microsoft teams. We've designed .NET Core to meet the needs of modern developers, so we've optimized it for writing cloud services and mobile apps. And it has a modular design so it can adapt to meet the needs of many different scenarios. Okay, so why are we making F# work on .NET Core? Well, there's a few reasons. The biggest one is that we want to give developers on OS X and Linux another way to use F# on those platforms in addition to Mono. This is to grow the F# community and get even more people to try it and use it, and it'll be great, I think. Second reason is that we expect a bunch of tooling and library and runtime and all kinds of innovation to happen because of .NET Core, because of bringing more people to the platform. And so we want F# to benefit from this wave of innovation that's coming. And the last reason is that F# has always played really well in mixed C#, VB, F# solutions. And so we want this to remain true with .NET Core. So that, for example, if you're writing an ASP.NET Core app and most of it uses C#, you should be able to incrementally introduce F# into that, and it should work great. So those are big reasons. Now today, F#, the compiler, and F# Interactive both run on Core CLR, and the .NET CLI tool supports F# in some important ways. But this is still a work in progress. So the biggest things are that most of the .NET library ecosystem has yet to be ported to .NET Core, and so you should expect to do some porting for the near future when you work with this. In particular, some F# type providers won't work because of changes to how reflection works for .NET Core. When you encounter issues when you try this stuff, make sure to help out the community and file issues, contribute fixes, provide ideas on GitHub. All right, that's enough explanation. Now let's see how to get started using F# on .NET Core. To get started, the first step is to download the .NET Core tools. To do that, go to aka.ms/.NET-Core-GS, .NET Core Getting Started, and this will take you to the .NET Core site. Now for this demo, I'm going to be using a Mac, but you could just as easily be using a Windows PC or a Linux PC, so then just follow the instructions on this site for the operating system you're using. There's even a Docker image if you prefer that. So I've already installed the .NET Core tools on this machine, but all you have to do is download this package and then follow the instructions in the installer. Once the installer completes, go to a terminal and type .NET, and you should see this output, and that lets you know that you've installed it correctly. Now what I'm going to do is make a new directory, and we'll just call it hello, and we'll go into that directory. And now I'll actually create my F# project on .NET Core. And to do that, I type .NET new -- lang F#. And so if you take one command away from this demo, this is the one. This is how you get started with F# on .NET Core. So we'll do this, and then look in that directory, and we'll see it's made 3 files. We have the F# program.fs file, we have a project.json, and we have a NuGet config. Okay, so how do we run this program we just created? Well, there's 2 steps. This is just like compiling a C# program on .NET Core if you've tried that. So you type .NET restore, and what this is going to do is look at the project.json file and download all of the dependencies we need for this program. This includes the F# compiler itself and the F# core library. And so once we've done a .NET restore, then we type .NET run, and this is actually going to compile our program and pass any command line arguments. And then you'll see here, hello world, and we have an empty, we didn't pass any command line arguments, so we have an empty array here. So the .NET CLI tool has been designed to make it really easy to operate from the command line. So if you prefer to edit your code from the terminal, the .NET CLI makes that workflow really easy. But I like using an editor, so I'm going to use VS Code. So you can download VS Code for free for Windows OS 10 or Linux from the VS Code site. And once you do, we can open the folder we were using. So I'll open our hello folder here. And so here we can see we have our Hello World program, our NuGet config. The NuGet config lists the different sources we're pulling NuGet packages from. We have our project.json and our project lock.json, which is generated by the .NET Restore, and this lists the actual specific implementations that are necessary to implement the packages that we're requesting in our project.json. So to explain project.json a little bit more, this is part of every .NET Core project, and it describes the structure of our program and any of the dependencies that we need. And so here we see it's finding the version number for our program, any compilation options. Here it says the compiler we're using is FSC, so the F# compiler instead of the C# compiler. We list the files that we're trying to compile, and I'll come back to this in a bit. Then it lists the different dependencies. So these are different NuGet packages that our program relies on. And so if you want to add a new dependency from NuGet, one way to do that, there are a bunch, but one way is to, let's say we want to add JSON.NET, we can just type Newtonsoft JSON, and you see here it pops up in this awesome autocomplete, and we can just press enter, and it'll autocomplete with the latest version of Newtonsoft JSON from the NuGet repository. And we won't actually include that, but so that's just one way to add dependencies in these projects. But let's just keep it simple here for now. So Hello World program is fine, but let's add another file. Let's see how to do that. Well, actually, before I do that, notice as I mouse around over this code that I'm not getting any IntelliSense for these functions and these values. And if I type system dot, I don't get any auto-completion. And so it'd be really nice to have this. And so luckily, the F# community has developed an awesome extension called Ionide. So to install a VS Code extension, it's really, really easy. You can go to View Command Palette, or I'm going to do Shift Command P on a Mac, and then type this, ext, to bring up extensions. You're sort of filtering through this command list, and we'll do Install Extension and type F#. And so here we see the Ionide F# extension. This is the one we want, so we're going to press Enter, and this is going to bring down the extension from the marketplace. All right, and it says it's installed, so we'll click Restart Now. This is going to refresh VS Code. And so now if I go and I type system dot, you'll see I get IntelliSense on all the members of that namespace, and I can mouse over functions and I get types for functions, and you can see it's inferring the type of the arg value argument. So it's all the IntelliSense and autocompletion you'd like from Visual Studio. It's right here in VS Code, so it's really, really nice. There's a bunch of other features of this Ionide extension that I'll demo in a bit. Now I should mention that the Ionide extension requires that Mono and the F# interactive are both on your path. So make sure to follow the instructions on the marketplace when you install this Ionide extension. But I already have those installed here, so we can keep going. All right, so this Hello World program is kind of boring, so let's add another file. Let's just add a simple library of some F# functions. And so I'll make a new namespace here. We'll call it hello module we can just call lib. And then let's just have some super simple functions. So maybe f of x squares x, g of x could be x times 42, and h of x could be 1 minus x. And see, this IntelliSense coming up, and I can mouse over these different arguments and see that it's inferring that x is an integer because we called the multiplication operator. So you can get all this great information from the compiler. This is using that inite extension. All right, so let's say we want to call this lib.fs, the code in libfs we've just defined. Well, to do that, we will add some structure here to our program fs. And then indent this. All right, now let's say we can take some numbers as arguments from the command line. So we can look here and we see that these arguments are strings in an array. And so if we want to operate on them as integers, like our libfs requires, we'll first map the int function over these strings using the F# pipe operator here. And then we'll map our lib.f function. And then we'll iterate over those integers that we've just produced and print them all to the console. We'll save this. And now, since the program.fs depends on our libfs file, we need to make sure to add libfs in the correct order in our project.json. And so in project.json, every time you add an F# file, you need to make sure you reference and you add that file to the list here in compile files, and you make sure you get them in the right order. So because program.fs depends on libfs, libfs needs to come before program.fs in this list. If you get the order wrong, you'll get a compile error that will say something like it can't find the module called lib. So watch out for that. But we got them in the right order here. And so now to run this program, it's really easy. We just say .NET run like we did before, and we can pass some arguments here that'll get passed through to the actual program. We'll push enter, and it was going to go read our project.json, know how to compile these together. And we see here, hello world, 1491625. So we got the output we expected. Now, so this is how you add multiple files in a project. But if you're like me, I spend a lot of time doing F# development from script files. And so it's really easy to work with those from inite also. So we're going to add a new file called script.fsx, it's an F# script file. And then we'll load the libfs library, and we'll open that namespace. And then I can just say let x equals lib dot. And you see here, we're getting completion on our lib library, and we get those types. So I can call f of 2. I can let y equal lib dot g of 4. Let z equals lib dot h of 42. And now, how do I run this? Well, you don't go to the command line again. This is just like in Visual Studio with the script file. You can select all of this, and then on a Windows PC, you do Alt-Enter, or on a Mac, you do Option-Enter. And this is going to send that code into the F# interactive prompt. And so it comes up here in VS Code thanks to that inite extension. And I can see here that I get the output I expected. Now, I should mention that this is currently using Mono. And so while we're running on .NET Core, when you compile from the terminal, when you're using this inite extension, this F# interactive is running on Mono. But so if you have differences, those may crop up, but for a lot of things, it'll work just fine to have the two different ones working. All right, so in review, to get started, go to aka.ms/.NET-Core-GS, stands for .NET Core Getting Started, and you can download the .NET Core tools there for your operating system of choice. Then to get started, make a new directory, and then call .NET new --lang F# to make a new F# project. It's that easy. There's a bunch of great resources online to help you learn more about .NET Core and F#. So the .NET Core website, which was .NETCore.github.io in this video, but that URL is probably going to change by the time you see it, provides all the documentation you need about the .NET Core APIs and the .NET Core tools. MSDN is an awesome resource about the F# language itself and the F# core libraries. To learn more about how to port your .NET Framework code to run on .NET Core, visit the .NET blog and look for a post called Porting to .NET Core, and expect more resources about porting in the near future. Finally, fsharp.org is an awesome resource about the open source F# language. And in particular, check out the testimonials page rather, that has dozens and dozens of examples of teams who are using F# in production really successfully. If you're interested in contributing ideas, fixes, issues, visit the 2 GitHub repos, github.com/.net for the .NET Core project and a bunch of other .NET projects, and then github/Microsoft/Visual F# to contribute to the Visual F# project. And if you're interested in reaching out to the team, tweet at us at Visual F#. Finally, I want to thank 2 people in the F# community in particular for contributing big features you've seen here today. Enrico Sada has done a ton of work to make F# work really, really well in the .NET CLI tool, and he's made some contributions to the F# compiler to support F# on .NET Core. And then Christoph Chaselak has built the INET extensions for VS Code and Atom that are really, really awesome ways to use F# on these different platforms. So thanks to both of them and everyone else who helps make F# so much fun. Thanks.